Okay, good morning. So today we're gonna finish section 4.3, logarithms, definition of logarithms and basic rules of logarithms will be over today. And let me go back a few slides back and review what we did on Friday. We learned first definition of a logarithm. Logarithms are inverses of exponential functions, and whenever you need to evaluate a logarithm, basic method is to convert that logarithmic equation into exponential equation and figure out what power of the base makes that number inside the logarithm. And this is what we did basically. What power of 7 is 49, and we figured out x equal 2, and we said this logarithm is 2. And now we learned that this is taking too long. Can we find out some basic properties of logarithms, and from now when we see them we can get the answers in 1 second? Yeah, such as if you have a number 1, no matter what the base is, it's always 0. If you have these two numbers matching, it's always 1. If you have a power raised to the raised in the base of b, and b is the same as the logarithm base, then these two kind of cancel and get x. And same way, if you have the base of the exponential and base of logarithm match, we can cancel and get x. So far we have 4, but these are only the basic ones. We are going to build 3 more today, and we'll gonna get 7 in total. Okay, 7 properties are going to be used in evaluating logarithms. And last time we finished with sketching logarithms. There are basically 2 graphs of logarithms. If the base is larger than 1, it goes up on the right side. If the base is less than 1, it goes down when the x's are getting larger and larger. Okay? So it either goes down, sliding graph, or climbing graph, rising graph. We have also mentioned that domain of logarithmic functions are always positive. Range is entire numbers, but the domain is always positive, very important. I think we finished. Have we finished this? We were about to, right? We didn't write the domain and range, have we? No? Okay, so why don't we transform logarithm base 3x and sketch this. We already did this part, I believe, but let's do this quickly. So log 3 crosses at 1. All logarithms crosses x-axis at 1, but since the base b is 3 and more than 1, it's a rising graph. Okay, this is log 3x only, but our actual function has 3 added. This is a left shift, and this is, it has a -1 on the right. This is downshift. So you need to move this 3 left, 1 down, 0, -1, and -2. This is the new location where it crosses, and I need to go down 1 here. So this point travels down here, and I need to make my final picture. Down here. Okay. Alright. I will clean the earlier versions. But I'm wondering where the new location this function crosses x-axis. I'm wondering what this point is. So how do you guys get x-axis x-intercept? What's that? We make y equals 0. Very good. So we set x equals 0 and solve for x now. I will add 1 to both sides. This is totally optional, but I'm just curious, okay? And now you need to answer this question. What number you're gonna insert here and add 3 and logarithm of it will be 1. You don't know how to solve these, but I think you can guess it. When logarithms become 1, logarithm becomes 1 if these two numbers match, right? So to be able to match these numbers, I need what here? No, I'm making a mistake. I think we've made a mistake here. Where is our mistake here in this graph? Because I see x equals 0 is the one that makes 1. Okay, I got the mistake. This picture is wrong, but I want you to find the mistake. Because I figured that according to this solution, x needs to be 0 to make logarithm base 3 equals 1. So x-intercept is 0, 0, 0. So this graph should have crossed x-axis here, not there. Where's my mistake? This is left 3, down 1, it's correct. But earlier, if you remember, I said when x is equal 1, this thing, I'm sorry, I said when x equal 1, this thing crosses x-axis, right? But it's correct. So we shift this 3 units left, 1. No, this is minus 2. This is minus 1. So I shifted 3 left. 1, 2, 3. Okay, minus 2. When I plug in minus 2, it drops to 1, 0, negative 1. So the only mistake is my initial estimate was wrong. This is not gonna cross here. It's gonna go a lot flatter. It's gonna go right here. At 1, it's gonna be 4, take away 1. Yeah, the only mistake I made is it's not going this sharp. It's just going that way. Okay? Alright? 0, 0 is the x-intercept. Alright. Now, noticing this, and this is the early picture I shifted off. This was earlier picture. This is log 3 of x, and here is minus 3. Earlier, before the shift, this was its vertical asymptote. Log 3x gets really close to this. Now the new vertical asymptote is, because we shifted this 3 left, the new vertical asymptote is 3. This is going to help us finding out domain and range. So can you tell me what's the domain of this blue line, blue curve? When I compress this up and down on this side, and I push it against x-axis, this is the image we get. We get minus 3 to infinity, right? Minus 3 is not included. Well, isn't it true that domain of this original function was 0 to infinity, as it's clear here? 0 to infinity is the default value of any logarithm bx. Then we shifted this 3 left. When I shift 0, 3 left, it's going to go to minus 3, of course. Okay? And it says write the equation of the asymptote. The new asymptote is the old one. Green one is x equals 0. If I shift the 3 left, it's x equal minus 3. Okay? Alright. So let's take a look at our homework. I think this was the last question before the final one. No, 17. Alright, first they want us to graph it, and we did. It was this, right? Minus 3. It's D. It's going down on the left side and going up on the right side, or maybe these two. So we need to be careful. No, this is on the shifted right side, and this is on the positive x-axis. No, it should be, which one? Which one is it? D, right? It's D. We're gonna write the domain. Domain is -3 to infinity. And range doesn't change. Still, it goes all the way down on the left side, so it is negative infinity. And it rises and rises indefinitely. It goes up and up, as you see in option D again, answer D. So the range doesn't change by shifts. Left or right shift doesn't matter. And the equation of the asymptote was -3. Okay. The next question is finding domain. I want you to still find the domain, but this time please do not waste to shift this right, left, or stretch, because there are shifts and stretches going on here. Don't do that. You don't have to. Can you definitely directly find the domain from the expression? So original domain, if it was only log 7 for just x, log 7 x, or log any base x as domain, as default 0 to infinity. We want to keep this positive. Only positive numbers are allowed. So can I use the same logic to this one? No matter what I insert into x, 4x, 4 times that x plus 5 must stay positive. What number do you think I should start with? Or do we need to guess this? What operation, what equation or inequality do we need to set up? can you change this, translate this into mathematical expression? 4x plus 5 must be definitely more than 0, not equal. You don't push equality because logarithm of 0 is undefined. Logarithms can't operate with zeros. So we want it to be more than 0. So we subtract 5 and then divide by 4 later, right? And get the domain. Domain is all numbers greater than minus 5 over 4, but they want it in interval notation. All numbers greater than this number is parentheses, start with that number, comma, infinity. Okay? So this is easy. You don't have to sketch anything. They're just asking what numbers make logarithm computable. Only positive makers. So the number, smallest number that makes inside positive is negative 4/5. And how far can we go on the right side? How big x can be indefinitely?
It's 5.
5, yeah, thank you. Alright, very good. Alright, there is one application of logarithms we are gonna cover now, and then there will be more in the other section, okay? 2 sections ahead. We will do more general applications there, but right now this is an immediate example of where widely logarithms are used. Actually, you don't feel earthquakes in Ohio, but in California and other regions of the earth, it's common. It's in their daily life. So I do personally know a size of earthquake 5 and 6 means. Okay, I know exactly how much that. Have you ever been in an earthquake? Have you ever feel it? Okay, so earthquakes, their intensity is described by numbers like size 5, size 6, size 7, size 8, size 9, and 10. It can go more and more, but I think the maximum ever happened is like size 10 or something in Japan. But the bigger the number is, the worse the earthquake is. Okay? And just because there is a difference of 1 doesn't mean it's just, okay, this is just the next size, but no. It's like 10 times the difference between each number. 10 times stronger shake. Okay? So that really matters. So how did they come up with these numbers? What scheme did they use? What formula they used? They used the formula, intensity formula. They first take a average number that's called I0. It's average intensity of an earthquake. Okay, so they start like 0 is set for numbers that like the starting number of all counting. 0 is set. I0 is the starting value of earthquakes, and you measure if it's more than this I0 value, you measure its rate to the original one. So you divide the measurement, your measurement, to the reference I0, reference value, okay, and take its logarithm to compute these numbers, size 5, size 6, or size 7. Alright? So again, somebody took a measurement, okay, and an earthquake happened, and they take an initial measurement from your device as 10 to the 10 raised to the 5 2 times the reference measurement taken, set up by scientists, okay? And then a few days later, you read more devices and devices, other reports coming into your center, and you revise that, oh, my first initial device in my center was incorrect. You change it into 10.5. 10 raised to the power 5.5. So this happens in the news, initial news. They say, okay, here is the scale of the earthquake, and then a couple days later they come up with a new number because more reports coming in. Okay, so what we are gonna do here is determine the magnitude of earthquake using the original estimate for intensity. You're gonna first determine the magnitude as a number 5, 6, 7, 8 using the original estimate. Original estimate initial reading was 10 raised to the 5.2. So we are gonna first compute logarithm of 10 5 to the 2 IO over I sub 0. Again, original measurement was 10 raised to the 5.2 times means dot multiplication I0. So this is the measurement your device gave you at that moment. And to compute it into publics, this is public scale, this is scientific scale. You want to change it into, when you're giving the news, you want to call the intensity of the earthquake as 5, 6, 7. You need to take this and divide by I0 and take logarithm. And when I take logarithm of this and cancel I0s, it's logarithm of 10 raised to the 5.2. Okay, you need to compute this. Well, especially without a calculator. I know you can put this into your calculator and compute this logarithm, but can we calculate this without my calculator? First of all, to be able to compute any logarithm, I need to know its base, and this doesn't have a base. Did they forget it? Is this a typo in their computation?
It's base 10.
Yeah, if you don't see any base, it's as default 10. So you need to use your laws of logarithm here and use one rule to cancel this number into better one. Which law are we going to use here? Which one? It's 3. If you have a logarithm with matching bases here, base of the exponential and base of the logarithm match, we kind of cancel this, and the result is 5.2. So it was a medium-sized scale. 5.2 is about an average earthquake. Okay, but later more reports came in, and the new number is 10.8. I'm sorry, 5.8. Guess what we are gonna do? In part B, we are going to check out the scale of the revised reading, which is 5.8. I think you know how to get this. You cancel these, and the new number is logarithm base 10 of 10 raised to the 5.8. These cancel, and we get 5.8. Okay? So it's about 10 times stronger, not about 6 times stronger, this one. Just take the ratio of these two. That's what we are gonna do. How many times more intensive was the earthquake? Again, when you tell somebody, oh, I had an earthquake of scale 5.8, and he says, oh, I had an earthquake of 5.2, you may say, not much difference, not much difference. Right? 0.2 to 0.8 doesn't seem like much, but it is actually much. Look, this is what the new measurement is. This is the original. Look, this is revised, and this is the original measurement. Let's take the ratio and see how much is the difference. 10, 5.8 10, 5.2. If you have two exponential expressions with the same base, I can combine them by subtracting their powers. You subtract the bottom one from the top, and this is 10 raised to the 0.6. Now take a calculator and compute 10 raised to the 0.6. So this is 10 raised to the 0.6. 3.981. So the new reading, new report, more healthier, much healthier report says you felt actually that earthquake was 4 times stronger. If I hold you and shake 4 times stronger, you will definitely feel the difference. So it's huge, 4 times much shake. Okay, so that's why revisions matter. Why don't we just set it 5.2? Why do we need to revise? Because that little difference in the decimals makes huge difference when you change it into base 10. Okay? Alright, 3.98, I rounded into 4 because it says 1 decimal value. That's what we're gonna enter into second one. Any questions? It's very, I mean, we didn't do any huge logarithmic computation here, but at least we have used one property that if you have a base and a base of the exponential and base of logarithm matching, we cancel it and compute 5 points. So these numbers, earthquake scales, actually computed using logarithms. Okay? So this is all. These are the basic rules of logarithms. Next we are going to build more rules of logarithms and start computing complicated expressions and combining them into single logarithms. And if you have a single logarithm, how do you break it into more logarithms? That's coming up next, 4.4. So what is new in this section? This is old rules. This is what's new. 5, 6, and 7. This is what's new. We are gonna go over these 3 first. First one called product property. If you have product of 2 numbers under the same logarithm, do you see the product sign here? X times y. You can break it as logarithm of the first number and logarithm of the second number. But watch out, what's the operation between these 2 logarithms? Is this a typo? I see multiplication between x and y. It turned into addition. No, this is not typo. This is actually one common mistake happens everywhere. You turn this logarithm into product of 2 logarithms, which is incorrect. It must be sum. When you multiply 2 numbers under the same logarithm, you actually separate those 2 numbers as a sum with each individual logarithm around those numbers. Second, when you have a division, look, do you see the division? This top was multiplication, this is division, and division is opposite of multiplication. So the sum turns into difference. Okay? So if you have a division of 2 numbers, or we call this a quotient technically, you take logarithm of the top is first, bottom is next. You take the logarithm of the bottom and take a difference. In multiplication, it doesn't matter which number you put first. You can put y and then x next if you like. But here it matters. Top must be first minus the bottom. Okay? The last one I already mentioned last time. I put it as number 5 in the last class. But let's go over again. If you have a logarithm with any kind of power inside on a different base, look, these are not matching, not match. It's not a match, but there is a power. You can take this power in front. But what happens if this is not x, but if this is a b? If it is a BBP, then we get, the answer is this. Do you see the difference? Because p goes in front, but logarithm of BB is 1, and 1 times p is p. That's why this is p. But the difference here is, on number 7 is, I'm gonna mark it here, this base is different than b. It's x or y or z, but it's definitely not p. Now what can we do? We cannot call this just p, but you bring that letter p outside and write the remaining logarithm as it is. Don't compute, reduce anything else. Okay? Now our first question is to figure out, simplify logarithm to 32z by writing as a sum of logarithms. It tells you which one of these rules to be used, and simplify if possible. So it says sum of logarithms, separate this as sum of logarithms. So we are going to use number 5 to break this logarithm into 2 or more pieces. How? Just figure out where the dot product is. Where is the product? It's right between 32 and z. There is a product here. If you see a product, I can write 2 separate logarithms, right? And the number before product goes to the left. The number after the product goes to the right, or number or expression. And what do I put between 2 logarithms? Plus. It's not product again, it's plus. This is essential. Alright. It says simplify if possible. Do you see any simplification? First, start with this. Can you compute this logarithm somehow or reduce things? Logarithm base 2 of z. I don't know z. I don't see a power around z. I don't see a number before z, so you can separate. Z is single. So this is not reducible, not possible for simplification. How about this side? Both numbers, especially the second one, is a kind of large number comparing the 2. So what do you think? Don't use a calculator. You should be able to do this by hand. 4. How did you get that? Yeah. The trick is always write that big fat number in powers, because we have a lot of power rules here and there. Logarithms are kind of vulnerable for powers. When powers show up, they reduce. So you need to turn this 32 into powers, and 32 is 2 times 2 times 2 times 2. Right? Actually start with 4 times 8 and break 4 and 8. And you get this. Is that right? No. You're short. This is 16. You need one more. Correct? 5. Because this is 4. This is 8. 4 times 8 is 32. So it's 2 to the 5th. Okay, now what do I do with this 5? So these are matching. So by rule number 2, they are canceling. Rule number 3, I'm sorry. Rule number 3 says this can be cancelled and it becomes only 5. Okay? Any questions? So you simply break the product as a sum and then simplify by using any of the other rules listed. Why don't you guys take a look at this? I put a list of rules on the right for you to refer to when you need it. What is the difference on this one? No, you can't type this like that. Alright, how do I make base of logarithms? To make a different base, you need to choose either this option to go do make a base, or choose shift underscore. It goes here, it's log base 2, then go to the right and type in Z. Alright, for this one, how many products do you see? I have 23. Is it just one? 23 times CD? No, there are two products here. 23, C and D. 3 terms, 2 products. Then what do I do first? Look, you have two options here. You can either break all 3 at once. This is the fast way. If you see 2 products, you make 2 sums and separate it. Or some people take their time and they do 1 product at a time. They separate 23 and CD first, 1 product, 23, and then CD, and then they separate this product as logarithm C, logarithm D. Same way, same result. You do 1 at a time or do all 3 at once. Okay? Question is, can I simplify them? By the way, if you don't see any base, do you see any base of the logarithm? No. That base is 10. Okay? Do you see any cancellations, reductions here? Anything? Only thing I will check out here, not these are fine, because they are single letters, no powers, no multiplications, no other operations. I can't reduce them. I was hoping to reduce this thing. It looks like a big number comparing to base, but 23, can you make it a power out of 23? Or even factors, can you separate it into more factors? No, it's prime. So this is my final answer. This is not reducible. Okay? So when I'm trying that, why don't you go check out this one? By the way, just copy this to every question. You will need this toolbox. keep it on the side. You're doing this. 15, base 15, C over D. I think there's a mistake I'm making now. No, it understands it. Usually I leave a space between log and C, but even you connect them, it still likes it. Good. Alright, what is the trick in this one? This is no-brainer. What operation do you see between terms? It's division, right? Or quotient. Then, anybody? You separate each C and D, top and bottom, top, bottom with a minus. Okay? I'm not even checking this. Oh, can I reduce these though? C and D? No, they're not numbers, they're not reducible. Alright, here. Just identify the operations among terms here and do accordingly. Yes, anybody wants to try their answer? Come on, somebody. Kylie, do you know the first step? Good. Kylie says there is a quotient here. We need to first separate top and bottom. This is top. This is bottom. We just need to make a minus between them. Okay. And if you need to show the base, these are 10. Is that all? Is this our final answer? What else can we do?
Can you separate negative 4 and 3?
Good question. Can we separate them? Let's check out our toolbox. Do we have a rule that says you can split a sum inside a logarithm? You need to see addition between terms. No, this is single power. It's not even. So this is a product. No, this is a division. This is a power. I don't see like logarithm b of, I don't see anything like this, x plus y. So can we make our rule and say logarithm x plus logarithm y? Can we separate like this, x and y? No. Unfortunately, there is no rule of addition. There is a rule of product, there is a rule of quotient, but no addition. We cannot separate it. I still don't want to quit. My question is, there is a power law there, P power. Can I factor this 4 out here? Can I call it outside? Can I? Yes or no?
It's not
Mm-hmm. To be able to factor something, look, here is the difference. That power you are calling outside must be the power of entire logarithm. This is okay. This can be moved out because 4 covers everybody inside parentheses raised to that 4. This moves out, okay, but this is not okay. 4 doesn't cover 3. Okay, so we are stuck with this one. This is locked. No reduction. No reduction. How about this one though? Can you reduce this? 1000 is a large number. I bet you can take the power of something and raise it to 1000, right? Make it 1000. What is that number? Should to the something? Now always go for a number that matches with this 10. It needs to be power of 10 so it can be useful. So is 1000 a power of 10? What power? Third power. Yes. Although we couldn't use the power rule for the second one, we can use the power rule for this one. Actually, no, not this one. Use the other power rule that cancels because 10 and 10 matches. So we have 3 left. Okay, and by the way, if there is an addition of 2 or more items, use parentheses because somebody can misread this and think 3 is outside the logarithm, like this one. Can somebody can think this is logarithm of 10 p to the 4 only, 3 is plus 3 is to the end of the expression. No, 3 is inside. So to make it clear to the reader, we put these 2 in parentheses so I know these 2 are both locked in this prison together. Okay, so this is the answer for question 4 in my set. We're gonna do this, but let me give you the toolbox. By the way, after a while, once you're done with the homework, you should be able to memorize these logarithms rules. You shouldn't have to take a peek at, okay? If you're still taking a look at this thing, that means you're not ready. So go practice more until you're independent from this tool. Alright, just think about this one. Base 4, 8 root of q to the 5th. Any ideas? Do you have any rule here that resolves any questions with radicals, square root, 8 root? I'm looking for a rule that can answer a question for square root, 8 root here. Anything with a radical? No. That means you guys need to do something about that radical. We can't move it. We can't answer it like this. Do you guys remember your radicals? Is there a way to change a radical? Like you guys, I think, did this earlier in this course. We changed this into power, you remember? How did we change it? What is the square root x in terms of a power? Anyone? It's x squared? No, it's not x squared. It's not x squared, it is x to the 1/2. How did they end up with 1/2? Because of this. There is an index 2 here. There is a power around x, invisible power 1. They simply put 1 to the top, 2 to the bottom. That's how they got it. So can I expand this into more numbers, such as x to the a, x to the b, and index b? If I have two numbers here, what is the rule? How do I convert this into power? Again, if this is 1 and 2, it's 1 over 2. 1 goes to the top, 2 goes to the bottom. If it is a and b, it is a over b. The inside power goes to the top, index goes to the bottom. Okay? Now, please use this here. Use this to convert this guy. It's q raised to what power? 5/8. Again, 5/8. Why am I changing a radical to power? What's the purpose of this? Why are we even bothering? Why do you think I made this step?
Use the power property.
Yeah, so we can use either property 3 or 7. There are two. We use 3 if these two numbers match. Are they matching? No, this is off the list. Then you're stuck with this one. If they are not matching, no match, we can still take care of this power by moving in front by rule number 7. Rule 7, which is 5/8 log 4 of q, and that's it. This is all you can do. Okay? Technically there is a secret rule number 8, but it's not covered in this class, in this textbook. If there is a power of the base, you can move it out as well. Do you know that rule? Like 4 is a power, isn't it? But I'm not gonna do it. I will just say it. I want to. Isn't 4 2 squared? Right? You can take this 2 to where? To next to 5? No. Since it's on the base side, it goes to the denominator. So it makes 5/16 logarithm base 2 of q. So any power on the base goes to the denominator. But we're not required to do it. It's not on the list. Okay, that's a good rule though. I don't know why they didn't take it. But this is your final answer. Alright, go ahead and think about this. I wonder what those two letters ln means. I don't see a logarithm here. Do you? ln is actually a logarithm, right? What does ln means? Log base e. Yes. So if you have ln 5, that's log base e of 5. Alright. Once we know that, so it's a logarithm, we can use all these rules. What rule are we going to use here? Logarithm base e of 5 raised to the kt. You see 1, b, b. It's 7 again. I see a logarithm with an exponential inside, exponent inside. So we can move, which exponent though we can move? K? Shall we only move k out? Both k and t. No matter how many items you have around the base, you take entire power in front. So it is kt times ln 5. Well, can I reduce ln 5 next? This is logarithm base e of 5. Can you raise 5 into more powers? Break it into numbers? No. This is already simple enough. So it is kt ln 5 the answer. Okay? To show you how to type in ln, there should be a button for this. kt, yeah, ln has its own button. This is it.
If you changed it to log E, it'll still take it out.
Alright, let's check. Log. Oops. Log base e o 5. It didn't like it now. Reset. I'm gonna use this button. No, it doesn't like log E. No, it's not that smart. So we have, whenever you have log base E, change it to ln. We actually never use log base E. Always we go with ln. Alright, next items is nothing new. It's just checking your ability to break a big fat logarithm into simpler pieces. Can you write this expression in terms of sum and differences? It's something we already done. You just need to break the operations here. Look, I see a division, I see multiplication, so I need to break this logarithm according to product and quotient property. But which one is first? Which one are you gonna do? Are you gonna first break product or division? Which one would you do? Come on, give me an answer. Choose one. Product or division? Division first. First separate top and bottom. So I separate top, I separate bottom with what? With a minus. Okay, next. I will apply, what rule can I apply to reduce in the first one? Power rule number 7. We can bring this power in front. 4 log 3r. Okay, I promised you there is a product here we need to separate, and I'm separating it next. Logarithm base 3 of s and logarithm of base 3 of t raised to the 6, and product separates with a sum. I make a sum. Okay? Yes, we can. Next, 3t raised to the power. These are not matching, no match, so I cannot use number 3. But at least there is a power, so we can move it in front. This is s. It looks like 5, but it's s. Alright, I have a mistake somewhere. Let's see who's gonna catch it. G? Oh, yeah. That's my poor spelling. That's log. Other than that, mathematical mistake.
This power of the 16 just go with p of x2. So you have to put, did it? Or because it was st to the power of 6. Does it go with that?
This x6 only covers t, not s. Yeah, if they use a parentheses, you're right. We need to move 6 first and break s and t. You were right that case, but no, this one has only t under 6. Yeah, I made a huge mistake here, that this minus a minus of this one item, when you break it into 2, it's still minus of these both items. So when I pass this minus in, it needs to make a minus here. Okay? Or shortly, if you don't want to make this step, here quickly make, if you don't want to use a parentheses here, quickly make this minus. This is now correct. You're too early. Log base 3 of r, 4 going in front, right? Minus log s minus 60, right? Oh, I missed bases. Where's my mistake? Yeah. Okay, this is it for today. We will continue this tomorrow.